All right, we are on question 5. So question 5 says, study the percentile chart in Annexure C and answer the questions that follow. So we're going to read here. This, you get it's there. That's the BMI. And then we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, okay. So the numbers are a little pushed aside. I don't know why. But if you read this, this is 2, 0, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, always make sure you're reading your graph correctly. Okay, so on this side we get the BMI again. This side you can read the BMI as well. And there's these lines. These lines, you follow the line, and in the end of the line there, you read the percentile. So these are the percentile, 3rd percentile, 4th, 5th, and 97th percentile, right? Coach Maxwell, the trainer at the local athletics club, uses percentile chart to determine the health status of athletes who are joining the club in order to determine the best exercise for them. Coach Maxwell allows athletes whose BMIs are between 5th and 85th percentile to join the club. What does the abbreviation BMI represent? So BMI stands for body mass index. Determine the maximum BMI that a boy should have to be able to join the club. So somebody who is the 85th percentile must be 27 BMI, and the measurement for BMI is kilograms per meter squared. So we're going to do that. So I'm going to say it's 27 kilograms per meter squared. Hence, determine a maximum weight of a boy who is 1.8 meters tall and whose BMI is considered healthy for a boy athlete. So if the maximum percentile is the maximum BMI is 27 and the height is 1.8, we use the formula. The formula says BMI is equal to weight in kilograms divided by height in meters squared, right? So what we're going to do is we're going to say this is actually height squared in meters, right? Okay, so BMI, we have the BMI. The BMI is 27 kilograms per meter squared. Also, remember that the weight is what we're looking for. They're saying we must look for the weight. So we divide the weight, which is supposed to be in kilograms, by the height of the kid, which is 1.8 meters. This is squared. And then we say 27 kilograms per meter squared is equal to the weight divided by what is 1,8 squared. 1,8 times 1,8 is 3,24 meters squared, right? And then now I'm going to do the part where 27 kilograms per meter squared is equal to weight divided by 3,24 meters squared. I'm just going to rewrite it for explanation purposes. You can do here. So now I need this number to go this side. It is dividing by 3.2. So what I'm going to do is I'm going to multiply by 3. The opposite of divide is multiply. 3.24 meters squared. That will cancel that, right? So I multiplied this side. So I'm going to come this side and also multiply by 3.24, right? So it's actually 27 kilograms per meter squared multiplied by 3,24 meters squared, and then is equal to weight, and then I just get the answer. 87.48 kilograms is equal to the weight, right? So that'll be the maximum weight for a kid who's 1.8 meters tall. And then we have 5.1.4, which says a 14-year-old boy who weighs 48 kilograms and whose height is 1.3 meters claims that he qualifies to be admitted to the club. Calculate the BMI of the boy. 0.4 BMI is equal to weight in kilograms divided by height squared in meters, right? So this time we are calculating the BMI. So the BMI is unknown and the weight is 48 kilograms divided by the height, 1,3 meters squared, right? So what we do now is we're going to say 1,3 times 1,3, that's going to be 1,69 meters squared, and then 48 kilograms BMI. Now we're going to get the answer. 48 divided by 1,69, that'll be 28,402366686 kilograms per meter squared.